All right, so today in 5.3, we're going to look at interpreting and sketching graphs. This is outcome R1. And I lost my pen. Oh, here it is. Okay, good. Okay, so we're going to look at this plot. What can you tell me is happening on this graph? This one here, where it says ages and heights of people. And then over here, this is heights and this is ages. So what are these dots representing?
They're representing the location.
So they are the ages of the people and their heights. Okay. So of here, which person is the oldest?
The one right at the top.
So the one with the... Okay, so this is ages. So if you're looking here at numbers, these are the ages going up, right? So this one here that's at the top, why is he this high? Because they are the tallest. So they are the furthest along because they are the oldest, and they are the highest because they are the tallest. Okay, so which person is the oldest? G. Which person is, what is their age? They are 18 years old. All right, so which person is the youngest? So you're looking along here, the one that's closest to the 0. What can you tell me, what do you think what can you tell me you're thinking about person A? Who could they be? A baby, a newborn. So they're 0, so they could be a newborn, right? A newborn baby. Which two people have the same heights, and what are you looking for on the graph? You're looking for two people that are horizontal to each other. So BC, so person B and person C are the same height. And what is their height? 100 centimeters tall. Okay, and now which two people are the same age? So what does that look like? They have the same vertical, so they have the same x value, right? Okay, there's two different y values. Hey, do you remember the function and relation idea? Would this be, could you call this a function or not? No. No, why not?
Because it has like 2 points of this.
Because right here, yeah, this vertical, two people have the same age, right? And they have two different heights. Okay, so person D and E, they are both how old? 10 years old. Okay, and now which of person B or C is taller for his or her age? So why would you say person B is taller for their age? Yeah, they are younger. And they're also the same height as person C, right? Okay. One last thing about this graph. What do we call this graph? What kind of a graph is it? So is it and here's a few different names of graphs. Is it a bar graph, a line graph, a scatter plot? What do you think it is? It's a scatter plot, okay? So it's a scatter plot because there are a bunch of dots scattered on the graph. Now, would it make sense to connect these dots together? No. No, because there's no connection here, right? It's separate pieces of information. They're not like moving into each other or going from one place to another. All right. Now let's look at this graph here. A day trip from Athabasca to Kikino. Now, this graph represents a day trip from Athabasca to Kikino in Alberta, a distance of approximately 140 kilometers. Describe the journey for each segment of the graph. So if it says that it's the distance, so you've got Athabasca to Kikino. So where would I look at this graph and think, okay, they are in Athabasca right now? So where do we start our trip? We start our trip at Athabasca. And then where do we go? Where do we go? This line, they're going somewhere. That's 140 kilometers away. So they're ending up in Kikino over here. And then when we come back, see, they're coming back, right? And now our distance from Athabasca is 0 again. What does that mean? That they are back in Athabasca. Okay, so does that kind of idea make sense? Does that flow make sense? So you're starting off at Athabasca, and then you're going 140 kilometers away, which is in Kikino, and then you're coming back to Athabasca. And now your distance to Athabasca, or from Athabasca, is 0. Okay, so now let's look at, what we're going to do is we're going to look at each line segment. So each section, the first one is OA. Our line looks like this, okay? Now, what is happening on the graph? So the line looks like it's going up and to the right, okay? So as time increases. Okay, so time increases in this direction. So that's kind of what we're going to be looking at. That's how we're going to look at this graph. And it is the distance from Athabasca increases. Okay, because we're going further away from Athabasca and we're going towards Kikino. So what is our average speed here? Do you remember distance time graphs from science? Okay, so we take the distance and we divide it by the time, and we end up with, so they're traveling 70 kilometers per hour. And what is the car doing? The car leaves Athabasca. Hopefully there's some people in it. And arrives in Kikino 2 hours later. Okay, so right here we're in Kikino now. So now what's happening in line segment AB? So that's from here to here. Is there any change in distance? No. So we've got a horizontal line, right? So this is a horizontal line. There is no change in distance. As time goes on. How long are they there, staying in one spot? So that's 1 hour, right, between the 2 and the 3? Okay, so the car stops. So maybe they're visiting someone in Kikino. They rest for an hour. They have lunch, maybe. All right, and now in segment BC, let's have a look at BC. What's happening? Where are they going? Where do you think they're going? Back towards where? Going back towards Athabasca. So now, what's happening? So the graph goes down to the right. Okay, so as time goes on, as time increases, As time increases, what happens? Distance to Athabasca. Yeah. Decreases. We're writing a story. That's exactly what we're doing. Yep. Yep. We're telling a story. The graph is telling us a story and we're interpreting it. So in this column, what we're doing is we're telling what the graph is doing. And in this column, we're kind of doing more of a story of what's happening in the journey. So for part BC, what do you think is happening in terms of the story? What can you tell me? So how long is this part of the story taking? How much time? So this is 1 hour from 3 to 4, but B, whoops, sorry, it's that, yeah, so around 45 minutes, right? So we return back home, so we're going towards, traveling towards Athabasca for 45 minutes. What's another way that I could say 45 minutes? 0.75 hours. Okay. The distance traveled, I only go how far? Traveled is 50 kilometers. Okay, can you tell me the speed of how fast the car was traveling for this chunk? So distance over time, right? So the speed is approximately, so we can go 50 kilometers over the 0.75 hours. And what does that give us? Around 66.6 repeater kilometers per hour. Let's just say 67 kilometers per hour. All right, so we're going a little slower than we were on the way up there, just a little bit slower. Maybe we're taking a different route, maybe the road's a little bumpier, maybe something's in the way, who knows, right? Okay, maybe someone else is driving. And then in CD, so let's go back to our graph and look at CD. What's happening in part CD? So they're resting again, whoops. So that's from here to here, they're resting again. So how long did they stop for? Let's look down here. Another 45 minutes? Okay, so my line looks horizontal, like that. Okay, so horizontal line, no change. No change in distance. As time goes on. Okay. Car stopped for 45 minutes. What do you think they're doing? Resting, having another snack. Car stops for 45 minutes. The car stopped 45 minutes. That's not very good English. Stops for 45 minutes or 0.75 hours. Okay? Maybe they're having another snack. Maybe they're taking pictures of a statue that they're seeing while they're driving by. Right? Okay, and then section DE. What's happening in section DE? Are they driving again? Yeah? Okay, so that's right here. Okay, so DE, they are driving, and where do they end up? They end up back at home. How do you know they end up back at home? Because they're 0 kilometers away from home or Athabasca. graph goes where? Goes down and to the right as time increases. All right, so they end up back at home. So the car takes 1 hour to travel all the way back home. Okay, and how far was it?
85 kilometers.
So right here, so we want to look at this between 80 and 100. We're going to say this is 90. Okay, and then this is 0. Okay, so they travel 90 kilometers back home. And what was their speed on this section of the trip? How much time did they take to go? 1 hour. So then what's our speed? 90 kilometers an hour. Okay, now notice that the car was going at different speeds each time, right? Different sections. Do you notice anything different about the steepness of this line and this line here? Because those are the two most drastic ones. What can you tell me? Which line is steeper?
The D2E.
So this is steeper?
Yeah.
And this is not as steep, right?
Yeah.
Not as steep. Steep. That's a P. Okay. So which one went faster? So you can tell that DE is faster than AO just by looking at the steepness of the line. Okay. So there's our little story. All right. Now, in this one, okay, so in this question, what we're going to do is we're going to read the situation, read the story, and we have to build the graph according to our story. So if you're looking at this, it says at the beginning of a race, Alicia, how do we say this name? Alicia? Okay. Alicia took 2 seconds to reach a speed of 8 meters per second. She ran approximately 8 meters per second for 12 seconds, then slowed down to a stop in 2 seconds. Sketch a graph of speed as a function of time. Label each section of your graph and explain what it represents. So what am I graphing? What's on my x-axis? What's on my y-axis? What goes down here? So this is time in what unit? Seconds. And what is this going to be here? Sketch a graph as, right here, it tells you right here, speed. Okay, so this is going to be speed. And what are the units for speed? Meters per second. Okay, so we've already got the numbers on our graph, right? Our scale is already done for us. So let's look at the first situation. The first little chunk of our story says Alicia took 2 seconds to reach a speed of 8 meters per second. So that means this is 0 and this is my 2, right? In 2 seconds, what does her speed start at? 0. And then she gets up to 8. So then it takes her 2 seconds to get from here to there, from 0 meters per second to 8 meters per second. So that's going to be our first line. Grab a ruler. draw the line. What does she do for the next chunk of the story? She ran for 12 seconds. So now here, this is I'm at 2 seconds. So where does 12 seconds take me up to? To 14 seconds. So that runs me into right there. And what speed does she go? 8 meters per second. So she's running a constant speed for, 8 seconds. Okay. All right, so that goes right up to here. So from here to here, she is running at 8 meters per second for 12 seconds. Her speed is constant, right? And now my line is horizontal because nothing's changing. Okay, and then what happens in the last little bit? Then she slows down to a stop in 2 seconds. Okay, so where should I end up? Past the graph. So my graph doesn't go far enough, so then I need to kind of just, I can say that that's 16, go off the graph a little bit, and then from here she slows down and we end up at 16 seconds. So here she's slowing down. Here her speed is increasing, and here her speed is decreasing. So you notice the way the line goes up and over to the right, and here the line goes down and over to the right? So, all right. Okay, now we need to write a little story about what's happening in each line segment. So let's do that. And what can I say is happening between? We'll call this O, we'll call this A, we'll call this B, and we'll call that C, where we end off. So what's happening in segment OA? Alicia's speed increases from 0 meters per second to 8 meters per second. So the line segment goes, oh, I'm having trouble writing, goes up and to the right. Okay, for the first 2 seconds. Okay. And in the second section where it's straight across, so that's this line segment here, and then this one here where it goes straight across, what's happening? Alicia runs at a constant rate, at a constant speed of 8 meters per second for 12 seconds. Her speed does not change. That's why the line stays horizontal. That's why. Okay. And now in BC, what's happening? That's where the line looks like this. So what's happening there? She is slowing down to a stop and takes 2 seconds to do so. All right. So the line segment goes down and to the right. All right. So now we've looked at a graph and we've told a story about the graph, and now we looked at a story and we made a graph from it, okay, depending on the information that's given. So a real good idea is to, when you're reading these little stories that you have to make graphs of, is to chunk them up into what's happening in each little section or in each little time interval, and think about it that way, all right? So you can kind of plan out what you're going to do. I forgot one thing on my graph. What can you tell me that I forgot on my graph? A title. Good. Okay, so what can we call this? I mean, it could be as simple as that. You just need to give it a title so that you know who it belongs to and what story it belongs to. All right. So your homework's at the bottom there. And, whoops. I'll fix that in a second. Hang on.